Now in physics there are two major categories for subatomic particles. One is called the hadrons, which we will cover today in this video, and the other one is leptons, which we will cover in another video. But like before we go on, let's check out this new lighting though. I look kind of brown. I mean I am, but not this brown. But I kind of need this new lamp because otherwise, yeah, it's looking kind of long. Now, what separates the difference between hadrons and leptons is that hadrons contain something that is called quarks. These hadrons are made up of these so-called quarks. So let's delve into the types of quarks that you need to remember for your exam. So the three types of quarks that you need to know are called the up, down, and strange quark. So let's look at some of the properties of these quarks. Well, let's start off with the charge. We're going to define charge relative to a proton or electron, which means that a proton will have a charge of +1 and an electron will have a charge of -1. An up quark has a charge of +2/3, a down quark has a charge of -1/3, and a strange quark has a charge of -1/3 as well. Now the baryon number of each of these is +1/3. For all these quantities, just take them as granted for now, and you'll find out more about how to use these later on in the video and when you do practice questions yourselves. And the strangeness for each of these quarks is 0, 0, and -1. Again, as I said, just take it for granted. At A level, you don't need to know what strangeness really means. Now, I've got this column here for antimatter, which is something that may be unfamiliar to you. Antimatter is a kind of particle or matter which is exactly opposite to normal matter. That means it will have the exact same mass as a normal matter, but in this case it will have the opposite charge, the exact opposite baryon number, and the exact opposite strangeness. And the antimatter for each of these particles are called the anti-up, which is denoted by this U with a dash on top, the anti-down, exactly the same, which is denoted by this D with a dash on top, and the anti-strange. I forgot to mention that you can represent these quarks by using lowercase letters U, D, and S. So for anti-up, it will have a charge of -2/3, a baryon number of -1/3, and a strangeness of 0. And let's say an anti-strange will have a charge of +1/3, -1/3 baryon number, and a strangeness of +1. So if I were you, I'd take a screenshot and make a note of this table so that you can refer to it as we go through this video. Now there are two types of hadrons that you need to know for your exam. One is called a baryon, and the other is called a meson. Now, a baryon is made up of three quarks, and a meson is made up of one quark and an antiquark. Examples of baryons are your protons and your neutrons. So let's start off by looking at some quark configurations of baryons. Now, as we know, baryons are made up of three quarks. And I said that an example of a baryon was this proton. Now, a proton has a quark configuration of up, up, and down. So if you look at the overall charge of a proton, we know that the up quarks each have a charge of +2/3, and the down quark has a charge of -1/3. So 2/3 plus 2/3 -1/3 will give the proton a charge of +1. And its baryon number is also +1. And you'll notice that it has 0 strangeness. Now the neutron, which you should also be quite familiar with, this has a quark configuration of up, down, down, which means that if you do the maths, the charge on the neutron is 2/3 -1/3 -1/3. So that will give it a charge of 0, which is what we expect. And it has a baryon number of +1 as well. And again, its strangeness is 0. And this is because it doesn't have any strange quarks. So why don't we look at the antiproton? And remember, I said that antiparticles are the exact opposite of regular particles. So the quark configuration of this antiproton will be anti-up, anti-up, and anti-down. So again, if you go through it, you'll get a charge of this time -1, a baryon number of -1, and once again a strangeness of 0. The other type of hadrons are called mesons. Now, as we said, mesons are made of a quark and an anti-quark. I don't know how good the audio on this is, but I keep hearing church bells ringing through the whole of this video. I hope it's not annoying you. It's annoying me. But alright, let's continue. There are two types of mesons that you need to know. One of them has no strangeness, and the other has strangeness. In this section, it'll be useful to refer to your quark table. So the types of mesons that have no strangeness are called pions. And there are three types of pions that you need to know. One is the pi plus, one is the pi naught, and the one is the pi minus. And what this plus, naught, and minus refers to is simply the charge on the pion. So let's look at the pi plus. We want there to be one quark and one antiquark. And remember that pions have zero strangeness. So what configuration of quark and antiquark will create a pion that has a charge of +1? If you look at your table, we can't use any strange or anti-strange quarks. So the quark configuration has to consist of either an up, down, or an anti-up or an anti-down. So in order to get a positive, we need an up quark and an anti-down quark. And the exact opposite is required for a pi minus meson. We want an anti-up quark and a down quark. Now for the pi naught, the only way we can get a charge of 0 without having an overall strangeness is by either having an up and an anti-up, or a down and an anti-down, or even a strange and an anti-strange. Because that way the overall strangeness on this particle is still 0. But the charge is still 0. But it still consists of one quark and an antiquark. Now the kind of mesons that have strangeness are called kaons. Again, you're going to have a plus, 0, and minus meson. But this time you're going to get a k plus, a k naught, and a k minus. So we want a strange or anti-strange quark in all of these mesons. So how can we get a charge of +1 using a quark and an antiquark where one of them is either a strange or an anti-strange? Well, if you look at your table, the only way to actually do that is by using an up quark and an anti-strange quark. And again, to get the k minus, you have to do the complete opposite and get an anti-up and a strange quark. Now there are two possible ways you can get a k naught meson, and that is by either having a down and an anti-strange, or an anti-down and a strange. As you can both see, both will have some sort of strangeness. One will have a strangeness of +1, the other one will have a strangeness of -1, and the overall charge on this particle will be 0. Now go have a watch of my videos on leptons, where you can find out about the electron and all of its cousins. Now the best piece of advice I can give you after watching that video is to go off and practice some past papers or topic questions. These are single-handedly the best way to help you commit the content you've learned to memory. Obviously go and do all the YouTube stuff of liking, subscribing, and if you found this video helpful, feel free to go and watch any of my other ones.